This is a walkthrough of Chapter 9, Text Processing, more about the wrapper class in the Starting Out with Java book. Alright, let's get to it. We're over in your clips, have a variety of projects. Gonna go from the start as though we're starting from scratch. Okay, gonna start a new project, new Java project. Giving it the name Manning Chapter 9. And finish. Okay, now I want to create a class. In order to make sure I put it in the proper folder over here, what I like to do is come over here and do a new Java class, give it just a temporary name, T, and see where it goes. It creates a little folder by the name of my project. That's the folder I want to drag my source code into that has been given to me. This is just a temporary file. I'll come back and work on that later. Or how about, or even better yet, I'm going to go ahead and add one. And in task number 2 on this project, we are creating a main from scratch that's going to be decoding a text file. So I might as well call that right now. I'll call it decoder. And the project is, or task number 2 is going to have us make a main. So I'm going to let Eclipse make the main for me. And finish. So that's what the decoder is going to be. We're going to be putting some code here that actually is going to read a text file and process it. It's going to be a very short program, but let's get the first part done first. Okay, so in the book, the downloaded labs, we have these 2 files that have been given to us. They do not compile initially. We have to fix them. But I'm going to drag them into my project, into that folder that was created for me, making a copy of them. That text file is going to eventually be opened by my main program. I'm going to put that text file in my project folder right there. Because my Java programs, when they do an open, they open from the project. That's where the binary runs, the executable runs. Okay, I don't need this T anymore. I'm going to right click, delete that. And yes, I'm sure. All right, let's take a look. The task number 3. Let's bring up the instructions for that real quick. Make sure we have them. Oh, where did I put them? Pause first. In the instructions for the lab, we're given the background. The military time project is going to be the second task where we process the file. But our first task is to fix the time.java code given to us, the time class that's going to, well, it has a method to check for a valid time that's been given to the constructor. Things that the time Java code needs to do, one at a time spelled out for us in thinking through the problem. Notice we didn't write any code. We just thought through what we need to do to solve the problem. Given a string that's supposed to represent military time, we check the length, that there's a colon in the middle. The other 2 characters on either side of the colon are digits. And figure out from those 2 strings on either side of the colon, convert those to numbers, or integers, and then we're going to, in the looping through input from the user, process that and just check whether they're done. That's a pretty easy change to that file. Inside the files are comments explaining what needs to be done. So let's bop over to the source code. Okay, let's open up time.java. Now when you first look at this, I'll double click here. First look at this, you'll panic, seeing red everywhere and wondering how in the world do I fix all of those problems? Well, don't worry. The comments are what's causing the problem. And because this if statement has many parts to it, it's bringing red errors way up to here, even though the first error is right here in this comment in the middle of the parenthesis. So I'm going to fix the code little by little here. And what I'm going to do, I'm going to leave the comment in there so I know what that was doing, why that particular section is there. In this first one, we're checking that there's 5 characters in the variable. As we read through this code, the variable given to us in the constructor is a variable called military time of type string. So I need to check whether military time has 5 characters, and that is done simply with this test. And if it doesn't have 5 characters, does not have 5 characters, that's when we want the error message to be printed. So we print out if military time, our string name, if his length is not equal to 5, dot length. And there's the piece of a string, there's the method of a string that returns its length. Now here's the piece of code that I like to do. I always like to put my constants on the left side, just in case I forget to do the double equal. In this case, length is also a constant. It will not take a value, so I could have put it on that side. Now there fixes that particular section of the if statement, leaving the comment showing this is where I made the change and what that was for. Here, check that the colon is in the correct spot. Well, the colon is expected to be at character position. Let's see, what would that be? 0, 0, 0, 1, 2. Position 2 is the center of a 5-character string. Okay, so I check that. Colon, the character colon, that's a single quote, colon is equal to military time dot, looking at a particular character at a spot, the charat. And the index is 2, 0, 1, 2. Position, the 3rd character, position 2. All right, there's that condition inside the parentheses of the if. I select that parenthesis, see, it shows me my matching parenthesis. All right, now this one, I see this multiple if statements, checking to see whether a digit is, each one of the digits is a, or each one of the characters is a digit. Well, let's do the first one. If, let's see, how do I check whether a character is a digit? Remember our wrapper class character. Dot is digit. Okay, so we can use is digit. Is, not is white space. Come on, I forgot to. Let's try that again. Is digit. There we go. Is digit. That character there is a character in military time. So that would be the character at position 0. So military time. How do I get the character at that position? Well, remember, it's charat. And position 0. All right, so that would solve that if statement. Test for is a digit, but I want this to check whether it's not a digit to give me the error message. So I put a not in front of that. And because I'm doing the same code 4 times, rather than repeat this system out print line 4 times, what I'm going to do, I'm going to delete all these other else ifs. I don't need them. And I'm going to check for all the other characters by checking the position of each one of them. If any of them are not a digit, then this will happen. So any condition, any of 4 conditions means I'm going to do a logical OR. So I'm going to copy this condition for position 0. And put another OR, logical OR, double vertical line. And that's at position 1. Another one, OR. Okay, we skip the colon and jump to position 0, 1, 2, 3. And then we say, okay, if any of those all ORed together are not a digit, if that one's not a digit, or that one's not a digit, or that one's not a digit, or that one's not a digit, then I will say not a valid military time. So if I have passed all the checks, if statements all along the way, nested together, if I have passed them, then I will reach the else. And this is where I then determine from the known digits in positions 0 and 1 and positions 3 and 4 what to do. Well, we see that the hours variable is where we're going to store the hours as declared way up here. Okay, so to read the hours, we have to look to another wrapper class that's been handy for us already, the integer wrapper class dot parseInt. Integer wrapper class parseInt will take a string and convert it to an integer. The string that we need is military time, but it's not the whole string, it's the first 2 characters. That's where I use the substring. I love the substring. Takes a begin index of 0, the first character, and ends before the last index. So that would be the first 2 characters. And I'm going to be assigning this to hours. So I say hours equals that. I have parsed the first 2 digits. Remember, that's where it starts. It ends 1 before that index. And because the minutes are very similar, I'm going to copy and paste that, changing my variable name, minutes, and that will be equal to starting at position 3 and ending before position 5. That will give me the minutes and a little bit of white space. That converts the first 2 characters in military time to an integer. Since I've already checked that they are digits, I know they are digits and this should pass. Another way I could have done it is simply check to see whether this returns or this causes an error. I could do a try catch. If integer parseInt fails, I know they have given me an integer. But we're going to write our code a little more carefully, do the checking this way instead. All right, that code should all compile. I'm saving this. All my errors are gone. Complaining about something up here. I'm going to ignore that for now. And fix a typo I noticed right there. Okay, now let's go over to the next part of this code, time demo. Time demo, they tell us in the comments here, I need to check what their answer was. And if they've answered yes, and initially we've set the value of answer to be the value y, and then when we come to this loop, we'll process what they enter for a time, and then ask them for an answer. And if they say anything except the letter y, we are going to stop the loop. So, assuming they have started, yes, they have answered y, how do we convert their answer? And I'm going to just put here, accept, we're going to accept the lowercase y or capital letter y. Anything else, will be considered a no. So they want us to check for answer is equal. Oh, this is where I want to put answer on the right side because I don't want to forget that. So I will get the character of what they answered. So I'll do character, not a character, the character wrapper class, converting whatever they answered to uppercase, to upper. What I'm converting to uppercase is their answer. Oh, and I forgot, that's not what I meant to put there. I'm going to compare converted uppercase of their answer to the letter capital Y. So if what they answered as a character, remember single quote means the character Y. If it is equal to the converted to uppercase of whatever their answer was, lowercase or uppercase y, then it will continue the loop. Saving that. That should be it. Now we have a complaint here. Oh, that was my problem. It doesn't like a package. This happens in Java. Remember that class that I created? Java or Eclipse likes to have that package line in there. I'm going to put that in my code, and then all should be good. I'm going to put I'll put the package name there. It likes to have that package declaration in there, or it will complain. The same thing here. Likes to have it before anything else. So this is because of the way Eclipse likes to organize my project. If I don't have that package declaration in there, it gives you that strange error. It's not very helpful. And see, that's where letting Eclipse make a class for you sometimes will help you catch those errors. Now, let's review what we've done. We have time demo that will, in a loop, keep asking us for an entry, assuming we've answered first before we come into the loop, assuming we've answered with a Y. Then it asks for a new answer whether or not I want to continue the loop. Well, then let's watch this run. I'm going to right click on that, run as Java application. Okay, let's give it some valid answers. 12:03, 12:03 p.m. Uh-oh. Something's wrong. Let's try another one. Yes, I want to continue. 13:00. Should be 1 o'clock. Uh-oh, got a problem. Better check. I probably have the wrong testing up there. Let's go back to here. What did I do wrong? Oh, not equal. What was I doing? I have to check that if it's not equal to length of 5, then it's a problem. If the cone is not equal to military time 2, then there's a problem. These were correct. All right. Now let's go back and test that again. Double click, run my program. Oh, I'm going to click no here, quit the program. And let's try getting that running again. Silly me. Run as Java application. Let's try that again. I should get 12 p.m. There we go. Try another one. 21:05. There you go. Let's try some error messages. Now in the problem they suggested some test values. Those are all good ones. Let's try some invalid inputs. Verify. I always want to try to break it. 7:45. It's not explaining what's wrong with it. That would be a better form of the program. Let's see. I'll give it a letter 3E:33. There we go. It's all working. Done.